Thousands of years, humanity has looked up at the night sky with wonder. Ancient civilizations observed the stars, mapped the constellations, and created stories about the cosmos. They had no rockets, no telescopes capable of seeing distant galaxies, and no understanding of the immense scale of the universe. Yet they shared something powerful with us, and that is curiosity. Today, humanity stands at the beginning of a new chapter in that ancient story. Space travel is no longer simply about launching satellites or sending a handful of astronauts into the orbit. We are entering an era where permanent settlements on the moon are being planned, human missions to Mars are actively being developed, and entirely new technologies are being designed to take us deeper into the space than ever before. The future of space travel is not merely a technological challenge, it is a human challenge. It requires courage, cooperation, innovation, and imagination. The same spirit that drove explorers across oceans centuries ago now drives engineers, scientists, astronauts, and dreamers to explore the vast frontier beyond the Earth. Many people ask why space travel matters. After all, our planet faces numerous challenges, including poverty, disease, climate change, and resource limitations. The answer lies in understanding that exploration has always expanded the human possibilities. Throughout history, societies that explored, discovered, and innovated often unlocked new opportunities that benefited the future generations. Space travel has already transformed our daily life. Weather forecasting, satellite communication, GPS navigation, disaster monitoring, and countless technological innovations originated from the space programs. The next generation of space exploration may bring even greater benefits. So, this video explores where humanity might be heading in the coming decades and the centuries. We will examine revolutionary spacecraft technologies, future moon bases, Mars colonies, asteroid mining, artificial intelligence, interstellar travel, and the major challenges that must be overcome. Most importantly, this journey is not only about the science and technology, it is about hope. It is about expanding the human story. It is about creating opportunities for the future generations to live, work, and explore beyond our home planet. The future of space travel represents one of humanity's greatest adventures. Whether we witness moon cities, Mars settlements, or missions to distant stars, one thing is certain: the story of exploration is far from over. The history of space travel is one of the most remarkable stories of human achievement. In just over a century, humanity progressed from powered flight to sending robotic spacecraft beyond the edge of our solar system. The modern space age officially began in 1957 when the Soviet Union launched Sputnik 1, the world's first artificial satellite. This small object orbiting the Earth changed history forever. For the first time, humanity has successfully placed a machine into the space. Only 4 years later, Yuri Gagarin became the first human to orbit Earth. His flight demonstrated that humans could survive and function in the space. It was a milestone that inspired millions around the world. Sorry. The 1960s saw intense competition during the space race. This period culminated in one of humanity's greatest achievements, the Apollo 11 moon landing in 1969, when Neil Armstrong stepped onto the lunar surface and declared it one giant leap for mankind. He symbolized humanity's ability to accomplish seemingly impossible goals. Following the Apollo era, attention shifted towards longer term space operations. The Space Shuttle program introduced reusable spacecraft concepts and enabled more frequent access to the orbit. The construction of the International Space Station demonstrated unprecedented international cooperation. The International Space Station became a laboratory where astronauts conducted scientific research while living in the space for extended periods. Lessons learned there continue to influence the plans for future missions to the moon and the Mars. In recent decades, commercial space companies have transformed the industry. Reusable rockets have dramatically lowered launch costs and increased mission frequency. What once required billions of dollars can now be accomplished more efficiently and sustainably. Today's space industry includes government agencies, private companies, universities, and international partnerships. Space is no longer the exclusive domain of a few superpowers. More countries and organizations are participating than ever before. This evolution teaches us an important lesson. Progress often occurs through gradual improvements rather than sudden breakthroughs. Every generation builds upon the achievements of those who came before. The spacecraft of the future may look as different from today's rockets as modern airplanes differ from the Wright brothers' first aircraft. By understanding how far we have come, we gain insights into how much farther we may yet to go. The future of space travel is built upon decades of innovation, perseverance, and collaboration. The next chapters may prove even more extraordinary than those already written. One of the most common questions about the space exploration is simple. Why should humanity explore space at all? The answer begins with understanding a fundamental characteristics of our species. Humans are explorers. Throughout history, curiosity has driven us to cross the oceans, climb mountains, study nature, and expand knowledge. Exploration is deeply embedded in the human civilization. Space exploration provides scientific opportunities unlike anything available on the Earth. By studying the planets, moons, asteroids, and distant galaxies, scientists gained insights into the origins of the solar systems and the universe itself. Exploration also drives technological innovation. Many technologies we use every day were originally developed for space missions. Satellite communications, advanced medical equipment, water purification systems, weather forecasting, and navigation technologies are just a few examples. Another important reason involves the long-term survival. Earth is our home, but it is not immune to risk. Asteroid impacts, natural disasters, environmental challenges, and other threats remind us that the placing all of humanity on a single planet carries vulnerabilities. Some scientists argue that becoming a multi-planet species could improve humanity's long-term resilience. Establishing settlements beyond Earth may one day serve as an insurance policy for the civilization. There is also an economic dimension. Entire industries may emerge around the space tourism, lunar development, asteroid mining, and advanced manufacturing in microgravity environments. Critics often argue that Earth should come first. In many ways, they are correct. Addressing challenges on the Earth remains essential. However, history suggests that exploration and solving earthly problems are not mutually exclusive. Investments in exploration frequently generates technologies and knowledge that benefits the society as a whole. Perhaps the most profound reason for exploration is inspiration. Great achievements inspire future generations to pursue science, engineering, education, and innovation. Space exploration reminds humanity that difficult challenges can be overcome through cooperation and determination. Ultimately, exploring the space is not about escaping Earth. It is about understanding our place in the universe, expanding human potential, and creating opportunities that may benefit generations yet to come. For most of the space age, rockets were used once and discarded. Imagine flying across the world in an airplane and throwing the aircraft away from a single trip. That was essentially how space transformation worked for decades. Rockets were incredibly expensive because nearly every launch required building an entirely new vehicle. Today, that reality is changing. Reusable rockets represent one of the most important breakthroughs in the modern space exploration. By landing and reusing rocket boosters, space companies have dramatically reduced the launch costs and increased the launch frequency. This innovation is often compared to the development of commercial aviation. Early aircraft were experimental, expensive, and limited. Over time, improvements made air travel safer, cheaper, and more accessible. Many experts believed reusable rockets could create a similar transformation for the space travel. Lower launch costs mean more scientific missions, more satellites, more opportunities for research, and eventually more people traveling beyond the Earth. Universities, startups, and smaller nations can now participate in activities that were once limited to major space powers. The future may bring fully reusable spacecraft capable of launching, landing, refueling, and flying again within the days. Such systems could support moon missions, Mars expeditions, and large-scale space infrastructure projects. However, challenges remain. Engineers must improve the reliability, safety, and operational efficiency. Spacecraft operating beyond Earth orbits face extreme conditions, including the radiation, temperature fluctuation, and long mission durations. Despite these challenges, reusable rockets are already reshaping the economics of space flight. Every successful landing demonstrates that what once seemed impossible can become the routine. History shows that transportation revolutions often change the civilization. Railroads transformed continents, commercial aviation connected the nations, reusable rockets may become the foundation of humanity's expansion into the solar system. Future generations may look back on today's reusable rockets as the first step towards a transportation network connecting Earth, the Moon, Mars, and beyond. The significance of this technology extends far beyond engineering. It symbolizes a shift from occasional exploration to sustainable access to the space. Humanity is beginning to build the infrastructure necessary for a permanent presence beyond the Earth. The journey is just beginning, but reusable rockets are helping transforming the science fiction into a reality. For most of history, visiting space was a privilege reserved for highly trained astronauts. Years of preparation, rigorous testing, and extraordinary physical fitness were required before anyone could leave the Earth. Today, a remarkable transition is underway. Space tourism is becoming a reality. The first generation of space tourists has already experienced suborbital flights, brief periods of weightlessness, and breathtaking views of Earth from above. While currently expensive, these experiences represents the early stages of an entirely new industry. Throughout history, new forms of travel often began as luxuries before becoming widely accessible. Air travel, automobiles, and even computers followed similar patterns. Initially costly and limited, they gradually became available to the millions of people. The future of space tourism may include orbital hotels, lunar sightseeing missions, and extended stays aboard commercial space stations. Some visionaries imagine luxury accommodations orbiting the Earth, offering panoramic views of our planet. Beyond entertainment, space tourism could have broader impacts. Increased demand may drive technological improvements, reduces the launch costs, and accelerate infrastructure development. Commercial investment could complement scientific and governmental exploration efforts. Many individuals who have viewed Earth from space describes a profound psychological experience known as the overview effect. Seeing our planet as a fragile blue sphere without visible national borders often inspires a deeper appreciation for humanity's shared future. Future tourists may become ambassadors for environmental awareness, international cooperation, and scientific curiosity. However, concerns also exist. Critics question whether space tourism primarily benefits wealthy individuals. Others worry about environmental impacts and resource allocation. These concerns are valid and deserves attention. Responsible development will require sustainable technologies, environmental consideration, and efforts to expand accessibility over the time. As technology improves, prices may decrease substantially. What seems exclusive today could become commonplace tomorrow. The long-term significance of space tourism extends beyond recreation. It helps normalize human presence in the space. The more people experience space firsthand, the stronger public support may become for exploration and the scientific advancement. One day, traveling to the orbit might feel as routine as boarding an international flight. While that future remains distant, the first steps are already being taken. Space tourism represents a fascinating glimpse into a future where space is not merely visited by spatialists, it becomes a destination for humanity. More than half a century has passed since humans last walked on the moon. Yet today, interest in returning to our nearest celestial neighbor has never been stronger. The moon is no longer viewed simply as a destination for short visits. Increasingly, scientists and engineers see it as a potential location for permanent human activity. A sustainable lunar presence could transform space exploration. The moon offers opportunities for scientific research, resource utilization, technology testing, and preparation for deeper space missions. One of the most important discoveries in recent decades is the presence of water ice near the moon's poles. This resource could prove incredibly valuable. Water supports life, but it can also be separated into hydrogen and oxygen for the rocket fuel. Imagine future spacecraft launching from lunar bases rather than Earth. Because the moon's gravity is much weaker, the transporting materials from the lunar surface requires far less energy. Permanent lunar settlements could include habitats protected from radiation, scientific laboratories, power generation systems, communication networks, and industrial facilities. Engineers are exploring innovative construction methods, including using lunar soil as a building material. Advanced robotics and 3D printing technologies may help create infrastructure before large numbers of humans arrive. The moon also offers unique scientific opportunities. Observatories located on the lunar far side could study the universe with minimal interference from Earth-based signals. International cooperation is likely to play a major role. Multiple nations and organizations are planning lunar missions, creating opportunities for shared research and development. Of course, challenges remain substantial. The lunar environment is harsh. Temperatures fluctuate dramatically. Radiation levels exceed those on the Earth. Lunar dust can damage equipment and pose health risks. The moon may become humanity's first true stepping stone into the solar system, just as sports enabled exploration across the Earth's oceans. Lunar bases could support exploration throughout the space. Future generations may view permanent lunar settlements as one of the most significant milestones in the human history. More importantly, returning to the moon represents something larger than the technology. It demonstrates humanity's willingness to continue exploring, learning, and expanding the boundaries of possibility. The moon is close enough to reach yet challenging enough to teach us valuable lessons. It may become the place where humanity learns how to live beyond the earth. And once that lesson is mastered, the path towards Mars and deeper space becomes much clearer. If the moon is humanity's stepping stone into the space, Mars is often considered the next great destination. Among the planets in our solar system, Mars offers the most realistic possibility for future human settlement. Although harsh and unforgiving, it poses characteristics that makes it uniquely attractive for the exploration. A Martian day is similar in length to Earth's. Polar ice caps exist. Evidence suggests that liquid water once flowed across its surface. Some resources necessary for the survival may potentially be extracted locally. Yet, traveling to the Mars remains one of the most difficult challenges ever attempted. A round trip mission could require years. Astronauts would face prolonged exposure to the radiation, isolation, communication delays, and psychological stress. Unlike missions to the moon, immediate rescue would not be possible. Future Mars crew must operate with extraordinary independence and resilience. Scientists are developing solutions for these challenges. Concepts include advanced life support systems, greenhouse agriculture, radiation shielding, and local resource utilization. Future settlers grow food inside protected habitats, recycle water continuously, and manufacture essential supplies using Martian materials. Mars exploration also raises profound scientific questions. Did life ever exist there? Could microbial organisms still survive beneath the surface? Discovering evidence of past or present life would revolutionize our understanding of biology and the universe. Many people envision Mars colonies as humanity's second home. While such ambitions remain decades away, significant progress continues. Robotic missions have already transformed our understanding of the planet. Future human missions will build upon that foundation. Mars represents more than a destination, it symbolizes humanity's willingness to confront extraordinary challenges. Success will not come easily, setbacks are inevitable. Yet history repeatedly demonstrates that difficult goals often inspire remarkable innovation. The first humans who set foot on the Mars will represent not only their nations but all of humanity. Their achievement will remind future generations that progress often begins when people choose to pursue goals that seems impossible. Mars is distant, dangerous, and demanding, yet it also represents hope, discovery, and the next chapter in humanity's story of exploration. Reaching another world is only the beginning. The greater challenge is learning how to live there. For humanity to become a true spacefaring civilization, future generations must develop sustainable habitats beyond the Earth. This requires creating environments where people can work, learn, raise families, and build communities. Scientists and engineers have proposed a wide variety of solutions. One possibility involves underground habitats beneath the surface of the Moon or Mars, natural protection from radiation and temperature extremes could improve safety. Another concept involves large rotating space stations that generate artificial gravity through centrifugal forces. These structures could support thousands of residents while orbiting the Earth, the Moon, or other destinations. Future habitats may include sorry, greenhouses, recycling systems, renewable energy sources, and advanced life support technologies designed to operate for years or even the decades. Food production will be especially important. Controlled agricultural systems will allow the settlers to grow vegetables, fruits, and other crops using minimal resources. Water recycling technologies will likely achieve extraordinary efficiency. Every drop will matter in the environments where resources are limited. Living on the other worlds will also require addressing psychological and social challenges. Human beings are social creatures. Successful settlements must support the mental health, education, recreation, culture, and community life. Future colonies may develop unique traditions and identities shaped by their environments. Children born on the Mars or in the space habitats could experience life very differently from the people on the Earth. Questions about the governance, citizenship, ethics, and cultural development will become increasingly important. Some scientists believe future settlements may eventually become self-sustaining. Others argue that Earth will remain essential for support for many generations. Regardless of the timeline, the efforts to create habitable environments beyond the Earth will drive major advances in engineering, biology, medicines, and environmental science. Most importantly, living on other worlds would fundamentally expand the human experience. Future generations may grow up seeing Earth not as the entirety of civilization, but as the birthplace of a civilization spread across the multiple worlds. Imagine a future where humanity no longer depends entirely on the Earth's resources. Instead, spacecraft travel to asteroids rich in metals, water, and minerals, extracting materials that help build cities in the space and support industries across the solar system. What sounds like science fiction today is becoming a serious field of scientific and commercial interest known as space mining. The solar system contains an astonishing abundance of resources. Certain asteroids contain concentrations of platinum, nickel, iron, cobalt, and rare earth elements. Some estimates suggest that a single metallic asteroid could contain more valuable metals than have been mined throughout all of human history. However, the greatest resources may not be precious metals. It may be the water. Water discovered on asteroids and the moon can be used for drinking, agriculture, oxygen production, and even rocket fuels. By splitting water into the hydrogen and oxygen, future space settlements could produce fuel without launching it from the Earth. This concept could fundamentally transform the space exploration. Instead of carrying every resource from the Earth, future missions might refuel and resupply using materials found throughout the solar system. Space mining could also support large-scale construction projects. Future habitats, solar power stations, and scientific facilities may be built using resources gathered in the space rather than launched from the Earth. The economic implications are enormous. Entire industries may emerge around asteroid prospecting, resource extraction, manufacturing, and the transportation. Just as Earth's industrial revolution transformed the civilization, a future space economy could reshape humanity's relationship with the resources. Yet, challenges remain significant. Mining in microgravity is vastly different from mining on the Earth. Equipment must function autonomously in extreme environments, often millions of kilometers from the human operators. International agreements and cooperation will likely play an essential role in addressing these issues. Despite uncertainties, the concept of utilizing space resources represents one of the most practical pathways towards sustainable exploration. For centuries, explorers relied on local resources to survive and expand into the new regions. Future space explorers may follow the same principles. The transition from carrying resources to producing resources in the space could mark the moment when humanity truly becomes a spacefaring civilization. What begins as mining asteroids may eventually become the foundation of an entire interplanetary economy. As humanity ventures farther into the space, astronauts will increasingly rely on a powerful partner, that is, artificial intelligence. Future space missions will involve enormous distances, communication delays, and complex operational challenges. Under these conditions, AI may become one of the most important technologies ever developed for the exploration. Today, robotic spacecraft already perform many autonomous tasks. They navigate, collect the scientific data, avoid the hazards, and manage onboard systems. Future generations of AI will be far more capable. Imagine astronauts traveling to the Mars. Communication with the Earth can take up to 20 minutes one way. In emergencies, waiting for the instructions from mission control may not be practical. Advanced AI systems could analyze the situations, diagnose technical problems, recommend solutions, and even carry out the repairs independently. Future robotic explorers may precede human missions, constructing habitats, deploying infrastructure, and preparing landing sites before astronauts arrive. AI-powered machines could operate continuously without fatigue, making them ideal for dangerous or repetitive tasks. Large construction projects on the Moon or Mars may rely heavily on intelligent robotic systems capable of building structures using local materials. Scientific discovery will also benefit enormously. AI can process vast amounts of data far faster than humans, identifying patterns and insights that might otherwise be overlooked. However, reliance on AI raises important questions. How much decision-making authority should machines possess? What happens if systems malfunction? How can safety and reliability be guaranteed? Engineers are actively working to ensure that future AI systems remain transparent, controllable, and trustworthy. This collaboration could dramatically expand humanity's capabilities. Throughout history, tools have amplified the human potential. AI may become the most powerful tool ever created for the exploration. The future explorers of space may not travel alone. They may be accompanied by the intelligent systems that help them survive, discover, and thrive in environments far beyond the Earth. So, in many ways, artificial intelligence could become the bridge that enables humanity to safely reach the next frontier. One of the greatest limitations of modern space travel is the speed. Although rockets today are extraordinarily powerful, journeys across the solar system still requires months or years. Reaching Mars takes many months. Reaching the outer planets can take years. Traveling to another star using current technology would require tens of thousands of years. If humanity hopes to become a true spacefaring civilization, new propulsion technologies must get emerged. Scientists are exploring several promising possibilities. Nuclear propulsion is among the most realistic near-term options. Nuclear thermal rockets could potentially reduce travel times to the Mars significantly compared to conventional chemical rockets. Another approach involves ion propulsion. These engines produces relatively low thrust but can operate continuously for long periods, gradually accelerating the spacecraft to impressive speeds. Some researchers even investigate theoretical concepts involving antimatter propulsion and advanced physics that remain far beyond current technological capabilities. Improved propulsion systems would do more than shorten the travel times. Faster journeys reduces radiation exposure, improve mission flexibility, and expand the range of destinations humans can realistically reach. Transportation infrastructure has always shaped the civilization. Roads, railways, ships, and aircraft connected the communities and economies. The spacecraft of the future may eventually carry humanity not only to the Mars but throughout the solar system and perhaps beyond that. What seems distant today could become commonplace for tomorrow. One of humanity's oldest questions is simple yet profound. Are we alone in the universe? For most of history, no one knew whether planets existed around other stars. Today, that uncertainty has largely disappeared. Astronomers have discovered thousands of exoplanets, worlds orbiting distant stars throughout our galaxy. Many of these planets differ dramatically from anything found in our solar system. Most exciting are the planets located within so-called habitable zones, regions where temperatures may allow liquid water to exist. Water is considered one of the essential ingredients for life as we know it. The discovery of extraterrestrial life, even microbial life, would rank among the most significant events in the human history. Such a discovery would transform science, philosophy, religion, and our understanding of humanity's place in the cosmos. Although current technology cannot transport humans to distant exoplanets, future generations may possess capabilities we can barely imagine today. The search for habitable worlds also provides a perspective. Observing other planets helps scientists better understand Earth's climate, atmosphere, and long-term future. Whether we eventually discover the life or not, the search itself enriches human knowledge and inspires future generations to continue exploring. The universe is vast, mysterious, and filled with possibilities waiting to be discovered. Perhaps no vision captures the imagination more powerfully than interstellar travel. Throughout history, Humans have expanded into new frontiers. We crossed continents, navigated the oceans, and eventually reached the space. The next frontier may lie beyond our solar system itself. The challenge is enormous. The nearest star system, Alpha Centauri, is approximately 4.37 light years away. Even traveling at extraordinary speeds by current standards, reaching it would require the thousands of years. One concept involves generation ships, massive spacecraft designed to support multiple generations of people during centuries long journeys. Another possibility involves suspended animation or advanced medical technologies that could dramatically extend human lifespan. Projects currently under study envision sending small robotic probes to nearby star systems within decades rather than centuries. Interstellar exploration would represent more than scientific achievement. It would symbolize humanity's willingness to pursue knowledge across unimaginable distances. Of course, enormous ethical and practical questions accompany such ambitions. Should humanity attempt interstellar colonization? How would communication work across the vast distances? And what responsibilities would explorers carry? The first ocean explorers could not see the continents they would eventually discover. Similarly, we cannot fully see the future that awaits beyond our solar system. Whether achieved in one century or many, the dream of reaching other stars continues to inspire scientists, engineers, and dreamers around the world. The stars that once guided ancient travelers may someday become destinations themselves. As inspiring as the future of space travel may be, but it is important to remember that every great journey comes with obstacles. The dream of becoming a multi-planetary civilization is not guaranteed. Earth's magnetic fields protect us from much of the harmful radiation that fills the space. Once astronauts leave Earth's protective environment, they face increased exposure to the cosmic rays and the solar radiation. During a mission to the Mars, astronauts could spend months or years exposed to these invisible hazards. The human body evolved under Earth's gravity. In microgravity, muscles weaken, bones loses the density, and bodily systems changes in the ways researchers are still trying to fully understand. Then there is the challenge of distance. Mars is millions of kilometers away. The outer planets are vastly farther. Interstellar destinations are almost unimaginable distant. Current propulsion systems limit travel speed, making missions lengthy and expensive. Space exploration requires substantial investment. Governments, private companies, researchers, and international organizations must balance the costs against competing priorities. As launch frequency increases, the industry must minimize environmental impacts and manage space debris responsibly. Protecting both Earth and space environments will become increasingly important. But challenges are not the reasons to stop exploring, they are the reasons to innovate. Every obstacle overcome teaches humanity something valuable. Every problem solved expands our capabilities. Every breakthrough brings the future closer. No major human endeavor is free from the debate, and space exploration is no exception. As excitement about the future space travel grows, important questions and criticisms continue to emerge. These discussions are valuable because they encourage society to think carefully about the priorities, ethics, and long term consequences. Rocket launches require significant energy and materials. As launch frequency increases, environmental sustainability becomes increasingly important. Critics worry about emissions, resource consumption, and the long-term ecological effects of large-scale space activities. The questions about the inequalities also gets a rise. Will future space travel benefit all humanity or only wealthy nations and corporations? If lunar resources or asteroid mining becomes profitable, who should be benefited? How can opportunities be shared fairly? Ethical concerns extend even further. Suppose microbial life is discovered on the Mars or elsewhere. Would humanity have the right to alter those environments through colonization? What responsibilities do explorers have when interacting with the other world? Interstellar exploration raises additional philosophical questions. Every transformative technology, from industrialization to aviation to the internet, generated report discussions about the risk and responsibilities. As humanity expands beyond the earth, wisdom may become just as important as technology. The controversies surrounding the space exploration remind us that progress requires both ambition and responsibility. Critics of space exploration raises important concerns. However, many experts argue that exploration and improving life on the Earth are not competing the goals. Many technologies that improve everyday life originated from the space programs. Satellite communications enables global connectivity, GPS navigation supports transportation and the commerce. Weather satellites help predict storms and protect the communities. Advanced medical technologies, water purification systems, and material science innovations all benefited from the space-related search. When scientists attempt to solve difficult problems in extreme environments, the resulting innovations frequently find applications on the Earth. The space industry supports high-skilled jobs, technological development, entrepreneurship, and international collaboration. New industries related to the transportation, manufacturing, communications, and research continues to get emerged. Exploration also strengthens international cooperation. The International Space Station demonstrated that nations with different histories and political systems can work together towards shared scientific goals. Future missions may continue fostering collaboration on a global scale. Earth is our home. Protecting it remains one of humanity's greatest responsibilities. But exploring space doesn't mean abandoning the Earth. In many ways, space exploration deepens appreciation for our planet. Exploration encourages the long-term thinking. It challenges the people to imagine the future, invest in the knowledge, and pursue solutions that may benefit the generations yet to come. The question is not whether humanity should care about the Earth or space. A thriving future requires solving earthly challenges while continuing to explore discover, and innovate. The future of space travel continues that tradition. Done responsibly, it can help humanity build a future that is more prosperous, more knowledgeable, and more connected than ever before. As we discuss future spacecraft, lunar cities, Mars settlements, and distant stars, it is easy to focus on the technology. The story of a space exploration is ultimately a story about the human beings. It is the story of scientists who spend decades studying the complex problems. It is the story of engineers who designed systems capable of surviving some of the harshest environments imaginable. It is the story of technicians, mathematicians, programmers, medical researchers, mission controllers, and countless others whose names may never appear in the history books. Every successful mission represents the combined effort of thousands of individuals working towards a common goal. We inherit knowledge from those who came before us. Future generations will inherit what we created today. Every telescope, spacecraft, scientific paper, educational program, and technological breakthrough contributes to a larger story. Exploration is not merely about the reaching destinations, it is about expanding the human understanding. It is about asking questions. It is about refusing to stop learning. The future of space travel rests upon the effort of countless dreamers who believed that the horizon could always be expanded. Their contributions remind us that extraordinary achievements often begin with ordinary people choosing to pursue extraordinary goals. Imagine standing beneath the night sky 100 years from now. Somewhere on the moon, children may look towards the earth and see the blue world where human civilization began. On Mars, communities may live within the protected cities, growing food, conducting research, and building new chapters of human history. Throughout the solar system, spacecraft may travel routinely between planets, moons, and orbital habitats. Scientific observatories may search distant galaxies, while robotic explorers venture into the regions never before visited. Perhaps one day, humanity may even send its first missions toward other stars. This vision may sound ambitious, yet throughout history, humanity has repeatedly achieved the goals that once seemed impossible. There was a time when crossing oceans appeared dangerous beyond imagination. There was a time when flying through the air seemed unrealistic. There was a time when reaching the moon existed only in stories. However, the true significance of space exploration is not measured by the distance, it is measured by the growth. Growth in the knowledge, growth in capability, and growth in understanding. The ultimate purpose of exploration is not to escape the earth, it is to better understand ourselves, our universe, and our potential. The stars remind us that humanity shares a common origin and a common future. From space, national borders disappear, political differences become less visible. What remains is a single planet carrying billions of people through an enormous universe. That perspective may be one of the greatest gifts exploration can offer. Future space travel may inspire greater cooperation, scientific literacy, environmental stewardship, and long term thinking. It may help humanity become not only more advanced but also wiser The challenges ahead are immense. There will be setbacks, there will be failures, there will be unexpected obstacles, but every great journey encounters difficulties. What matters is the willingness to continue moving forward. The future is not something humanity passively waits for, it is something humanity actively creates. Every student studying the science today, every engineer designing new technologies, every educator inspiring curiosity, every researcher seeking answers, every dreamer imagining the possibilities, all are helping shaping the future. The story of a space travel is still in its opening chapters. The greatest journeys may not yet have begun. The next giant leap for humanity may be waiting just beyond the horizon. And perhaps one day, when future generations look back on this era, they will remember it as the moment, sorry, when humanity chose not merely to look at the stars, but to reach them. The future of a space travel is not only about exploring the universe, it is about discovering what humanity can become when curiosity, courage, and cooperation unite in the pursuit of a shared dream. Thank you.